Hi guys, welcome to this video, and today we are going to learn how to calculate band gap energy from UV visible absorption spectrum with the help of origin. Firstly, we have to convert the wavelength into energy, that is equal to hc by lambda, and we can calculate it directly with the help of 1240 divided by lambda, which is in nanometer, and we can get the energy which is in electron volt. Secondly, we have to convert absorbance to absorption coefficient by with the help of this equation alpha, which is equals to 2.303 into absorption upon length of this cuvette. The length of cuvette is standard is 1 centimeter, so we have to calculate directly. Alpha is equals to 2.303 multiplied by absorption. Now here we have the UV absorption data. In column A, here is that wavelength, and in column B, here is the absorbance. Now firstly we have to calculate this absorption coefficient, which is whose unit is centimeter inverse, and it is represented by alpha. So to calculate alpha, we have to do that 2.303 multiplied by absorbance alpha, whose unit is alpha, whose unit is centimeter inverse, and in column C, here is the absorption coefficient, whose unit is centimeter inverse, and its symbol is alpha. To calculate alpha, we have to multiply 2.303 by absorbance. Here is the column B, and then the absorption coefficient that we have. Now to calculate the energy, and whose unit is electron volt and is represented by the h mu. To calculate that the energy, which is equals to 1240 divided by the lambda, which is column A. Now we have the values, and after that this equation is for the direct band gap, when in column E we have the alpha h mu whole square. To calculate it, we have to multiply alpha into h mu. To calculate it, we have to apply a formula, that is column C multiply by column D, alpha into h mu, and whose power and whose, and just add a square, or we can also do that set this column as x-axis and this alpha h mu whole square is y-axis, and just plot it. Here we get the graph, and now you just have to mark the line after that hump at which it intersect will be its band gap. Just increase the width of the line, and use this screen reader tool to get the band gap, which is the direct band gap is 3.556. And right, direct band gap, and to set its formatting, I will previously one graph. I just copy the layout from here and just paste it here. Now we have a graph like that.